You know, every time you send an email or stream a video or just browse a web page, you're tapping into this massive, invisible architecture that pretty much runs our modern world. Today, we're going to pull back that curtain and take a look at computer networks. It really does feel like magic, doesn't it? You click a link and a website from halfway around the world just appears. But how does that actually happen? How does one little click travel all that way in the blink of an eye? Well, that's the big question we're going to tackle together. Let's dive in. All right, so to understand how that global click works, we've got to start small. And I mean really small. We have to go back to the most basic idea of all. What even is a network? At its heart, it really is this simple. You take a couple of computers, maybe some other gadgets, you link them up, and boom, you've got yourself a network. And the whole reason we do this, it really boils down to two huge things: sharing stuff and sharing information. And the benefits here are just so practical. I mean, think about it. For resource sharing, instead of buying a printer for every single desk in an office, you just hook one up to the network and suddenly everyone can use it. For information, instead of passing around a USB stick, everyone can get to the same files on a shared drive instantly. And naturally, all of this saves a ton of money and just makes everything way more efficient.
But of course, it's not like all networks are the same. They come in all different shapes and sizes, from the tiny one that connects your earbuds to your phone, all the way up to the internet itself. So let's take a look at how they scale. We're going to start with the smallest of the small, a personal area network, or PAN. And it's exactly what it sounds like. It's that little personal bubble of connectivity that follows you around. When your phone pairs with your wireless headphones using Bluetooth, that's a PAN. When your smartwatch syncs up with your laptop, you're using a PAN. Okay, let's zoom out a little bit. A local area network, or LAN, connects all the devices in one place, like your home or your office. You know that Wi-Fi network that links your laptop, your smart TV, and your phone all together? Yep, that is your very own LAN. It's probably the network you interact with the most every single day. And finally, we get to the big one, a wide area network, or WAN. This is what connects different LANs together, often over massive distances. When an office in New York needs to connect to its branch in London, they're using a WAN. And here's the real kicker. The internet? It's the ultimate WAN. It's just one giant globe-spanning network made up of countless smaller networks. So we get that networks connect devices, but how are they actually arranged? This part I find is super interesting. Just like a house needs a blueprint, a network needs a physical layout. In the networking world, we call this a topology. Let's look at a couple of the classic designs. This really lays out the trade-offs, doesn't it? On the left, you've got the star topology, where everything connects to a central point, kind of like spokes on a wheel. This is pretty common today. It's great because if one computer dies, it doesn't bother anyone else. But you see that single point of failure. If that central hub goes down, the whole network is dead. Now, on the right is the bus topology. It's simpler, cheaper, everyone just taps into one main cable. This was popular in the early days, but the problem is obvious. If someone trips and pulls that main cable out, the entire network just goes dark. So you see, different blueprints for different needs. Okay, so we've got our blueprint. Now we need the actual stuff, right? The physical building blocks, the hardware that makes a network come to life. I bet you've seen a few of these boxes sitting around your house. Every single one has a job to do, but for your home internet, we're going to focus on the two big ones, the translator and the traffic cop. First up, the modem. The easiest way to think of a modem is as a translator. So your computer speaks a digital language, all ones and zeros. But the internet infrastructure that comes into your house, like a cable line, often speaks in analog signals. Think waves. The modem's job is to sit in the middle and translate. It modulates the digital signal into analog to send it out, and then demodulates the incoming analog signal back into digital that your computer can understand. And next, we have the router. So if the modem is the translator, the router is the traffic cop for your home network. It takes all that data coming in from the modem and directs it to the right device. It's the thing that says, okay, this piece of data is for the laptop, that one's for the gaming console, and this one over here is for your phone. It makes sure everything gets exactly where it needs to go, and fast. So we have the basic ideas, we have the different scales, we have the blueprints, and we have the hardware. Now, let's talk about the main event. Let's see how all these pieces came together back in the 1960s to create the biggest, most ambitious network of them all, the internet. This whole story starts with a US military project called ARPANET, and the very first message they tried to send, back in 1969, was the word login. So they typed an L, and it showed up on the other computer. Success. They typed an O, it appeared too. Amazing. Then they typed a G, and the whole system crashed. So the first message ever sent across the internet's ancestor was just LO. How about that? From that incredibly shaky start, things like email and eventually the World Wide Web turned this little experiment into the global force we know today. So what was the secret sauce? What was the breakthrough that made ARPANET work and ultimately made the modern internet possible? It was this brilliant idea: packet switching. Instead of sending a big file as one long, fragile stream, you chop it up into tiny little pieces called packets. You slap an address on each one, and you send them out into the network. They might all take different paths to get there, but they're all put back together in the right order at the destination. This makes the network incredibly tough and efficient. If one road is blocked, the packets just find another way around. It's genius. And from these simple parts, from nodes and connections and hardware and packet switching, something emerged that was so big, so complex, that it led former Google CEO Eric Schmidt to say this: "The internet is the first thing that humanity has built that humanity doesn't understand. The largest experiment in anarchy that we have ever had. It's just this incredible, decentralized achievement." So we've journeyed from a two-letter message that broke the system all the way to a global network connecting billions of us. We've looked at the basic ideas, the different sizes, and the gear that makes it all possible. The question now is, what comes next? With stuff like 5G, the Internet of Things, and global satellite internet becoming a reality, where does the story of connection go from here? It is a pretty exciting future to think about. Thanks so much for joining me.